Yeah. Okay. So first of all, I feel a little bit out of place here because my talk is not as deadly serious as all the other talks. I was at the first talk I thought, oh, it's a fluke. Maybe the others are a bit more light, but no, they're all serious. So, well, mine isn't. Okay, so surprise, click, engage, and so on. I am CTO of a company in Amsterdam since 14 years, and we make enterprise software stuff, serious stuff with Java and OSGI. That's really, really very serious. And we are mostly focused on sports and entertainment. Is also serious, depends on how you look at it. 2 years ago, we started a spin-off called Sendrato. Sendrato actually means wireless in Esperanto, the language nobody speaks. And I'm senior technology architect. I made that up because I thought it would look nice on a business card, but I'm not really an architect. I make stuff. So that landed us a nice award last season. We are Innovator of the Year in the Wearable Technologies of the World Cup. So I'm going to talk about the technology we do a little bit. Then I'm going to do a completely doomed demo, because that always happens in demos. And if you have the only demo so far on a conference, okay, we'll see. And then I will talk about my personal journey a little bit, because I'm really like a native software guy. I always build only software. And now you get down through all the virtualization to hardware. And that's actually a very interesting experience. So our product here at Sendrato is a wristband. And that's an example of a wristband. You put it around your wrist, and then things happen. So before we talk about that, if we strip it down, we see this is basically the unit. It's flexible, you can bend it, it's very comfortable and easy to embed. It has an 8-bit microcontroller and a 900 megahertz radio. So an 8-bit microcontroller does not run Java. It also doesn't run Docker. So deploying stuff on there is messier. There's also an RFID tag. That's not all that special, but it's still cool. There are 2 LEDs which are multicolor, and there's a button you can press, and then something completely undefined happens. Okay, so it looks like this if you put it on nice-looking, cool people. So the other part of the technology is our base station. So that's the hardware that talks to over the 900 megahertz radio to the bracelets, right? So those are for festivals. We put them around the festival, and they communicate with the wristband. So if we zoom in a little bit on that thing, we see different parts. It's not that visible, but I probably don't want to turn off the lights. In the middle is a QB truck. It's a sort of Raspberry Pi. It's ARM-based and runs Linux, Fedora, and Java, and OSGI. It even seems to run Docker, but I haven't gone around to that, sorry. I'll try later. On top is power over Ethernet. It's powered by Ethernet. And on the right, I want to just point out some really rugged piece of hardware. It's actually a lightning surge protector. So if this thing gets struck by lightning, it's supposed to survive. It never happened. I was hoping for it, because I will want to see if that little thing will save that QE, but we'll find out at some point, I guess. So when we have a festival, we put those base stations up on objects, whatever we can find that's more or less stable. We tie them to that, and then so we can cover the area. Okay, so once we are set up, the different base stations start to see each other and form a mesh network, because they need to do that, because they need to have a very strict synchronization between each other, because the stuff we do is really time sensitive. So they need to see each other. So this is a part of a map. So here you see 1, 2, 3, 4, 5, 6, 7. In total on a large festival we have about 60. And all those things are powered by Ethernet and they have their own network connection. So, what can this thing do? So we have basically bidirectional communication between the wristbands and the base stations. And what we can do with that is low resolution positioning. So the wristband basically says, I see these, and these base stations, and they seem this powerful, the signal is this strong, and it reports that up to the base station that will ship it further down the line. And based on that, you can make some assumptions with triangulation where that person is. We can also use the lights, the LED lights on the wristband, to create cool light shows. So then the base station broadcasts to the wristbands to turn the light on in a certain color or off. Another thing we can do is to imagine this. There are like two people with a bracelet and they like each other and they can like connect each other, and then the bracelet will connect with each other, and then they will tell the system these two people have been connected, and then our social media platform will make a Facebook suggestion out of that. So, and it's also a button on it, and it can detect that button, and what happens then is up to the festival, I guess. So yeah, why would anyone want to do this? Well, big data basically. The big thing is profiling people, because if you have a festival, there are multiple stages, people walk around, and it's really nice for an organizer to know where they were. How long did they hang out here? To which artists were they interested in? So that's actually really valuable data. The light shows for the LEDs are of course very nice because it really integrates with the people. And I think also it's kind of essential to give the user something back. Because otherwise it's like, here's your tracking beacon, now go play. So you have to sort of give something back. The social media connects are obvious. And also the RFID chip, that's like very traditional stuff. You can use it to gain access to stuff. You can use it to buy stuff for payment. And also, for example, we have photographers making pictures, and then they can scan your wristband, and then you'll get that picture. So another nice thing to do for the security guys, different kind of security, is a crowd density map of the terrain. So they can have like a weather map. They can see where the crowds are and more or less how it's divided. It is not like very accurate. It's like easily 10-20 meters off, and it's updated every few minutes, depending on the number of bracelets. We aim at over 100,000, so that's quite a lot of bracelets. So I think it's time to do the demo. So, one moment. So I have here two bracelets, and I have here an iPad, and tricky. How do I do that? So if I press this, then oh, this is so beautiful. Then I can make different colors. Yeah. Only one guy applauding. So we can also do the other thing, the connection thing. So if I hold it, starts blinking blue, and this one too. And if I hold them together, at some point they're green, and then they're connected. So basically what happens then is that they power down their radio way low until they have only a range of like a few centimeters, and then they can, in a peer-to-peer way, figure out that they're connected. It's actually quite important for at that scale that they can do it peer-to-peer. And then once they both figured out they're connected, they will try to offload the data to a base station whenever that's possible. Okay. So it doesn't really look that impressive with one guy wearing two wristbands. So it looks a bit better on a video. Maybe we can turn off that light? Just for a moment. Maybe that one too. Yeah, can you turn it off? So you have sound, I think. We don't have sound. Can you turn off unmute number 5? You got to do everything. Unmute something else. Huh. Well, that was the thing that was gonna fail, I guess. That's unimpressive. But still, here you see 100,000 people wearing their bracelets. It's cooler with music, but it's it's the main stage at a large festival, and it's it's pretty massive. Scary, actually. It's too many people for me. This is a crowd. That's insane. Okay. I see some different colors: red, blue. Yeah. Okay. So now I want to move on to the actual more stuff we are about here, and that's like the production process. In software, we call it the build. In hardware, it's a bit more complicated. If we walk through it, we start with a PCB design, so that's basically the chip design, which chips go on there. That is oh yeah, they switched on. Thank you. And a firmware design, so that's basically the low-level software that runs on the 8-bit controller. Then we have a prototype, and we can play around with it a little bit. Actually, the design of the leather band and everything, that's really closely communicated with the client because they want to brand it with their own logos and everything. So that's done by fashion people and so on. And they make it pretty. And then they make a mock-up. And then they assemble it. So the PCBs are assembled in Singapore. They ship it to Italy. They assemble the prototype. Then they test if it works, because they already do that. If it's a test run, they ship it to Amsterdam to us, and then we can play around with it to see if they're happy, if we're happy. And if not, we can actually reflash the firmware, but that's a quite intensive process, so that's not something we can do in production. So if it's all right, then it ships to Belgium, and they will make a nice box and they package it, all 100,000 of them. And they will ship it to the consumer, and then the consumer will put it on their wrist, and they go to the festival, and then they show up, and then it should work. Now, I think you can imagine that this part after test is terrifying, because you have committed for about $1 million worth of hardware that firmware is okay. So, well, that isn't very agile. But yeah, sometimes that's the way it is. So, still, if you think about it, compared to only like several years ago, having the development cycles of a few weeks in hardware is pretty good. You can actually do stuff with that. So, so how did we end up here? That's a question I have asked myself many times over the last few days. I was talking to a guy at the meetup, and now I'm here. So there is no gadget track, but there is, I think, a story to tell, because we have been talking about how early software was designed by hardware engineers, right? We built, at first we were used to building bridges and cars, and then you think, well, we built software just in the same way, right? And later on we have kind of figured out that in software you can get away with a lot of things where you can't get away with hardware because of that cycle, right? So you can just try stuff, not good, and turn it back. So we have been doing that, and we have really gotten used to that. And now we have like the cloud native application we've been talking about a lot. And that basically is like another layer of virtualization. So basically we write code, we write some kind of declarative manifest how it's supposed to run. We hand it over to some data center OS, some Kubernetes or whatever, and then some unopinionated paths, and then everything will work out. But in the end, it's like a long dash running away from hardware. And me, in my software job, I am running Java virtual machines inside containers on virtualized stuff. And that's, for me, it was really good to get back through all those layers of virtualization and see hardware again. Because, that was the, yeah. So I think it is good to realize that again, because we have, I think, we software people have gotten spoiled. Because we can do anything, and if it's not good, we can undo it. And we don't really need to think about it. And that's like really the big power of software. But it does make, you do lose some bigger picture, I think. I mean, mankind has been making stuff for years that wasn't, for millennia, that wasn't agile, and they got along also. So, yes, so the things, lean, agile, and rugged. Actually, I didn't know that I was going to be in agile. So I thought those three. So I am far from an expert of talking on any of these things. So I will put those in a wearable context, right? What does this mean for a wearable thing? Well, agile wearables, as we talked about, we can't change hardware that's around somebody's wrist. You can't change any hardware, actually. At the moment, we can't update firmware. We could figure out a way that we can over the air push new firmware images, but that's quite an undertaking for an 8-bit microcontroller to do that in a secure way and not open up all kind of problems, because if that upgrade fails, then it's dead, right? So, but we can upgrade everything else. So whatever we have, the whole software stack that does the interesting stuff, that is agile. So we have to focus on that. So if we move on to lean, I think an important thing for wearables is that it's wearable, right? That many of the old school wearables, you can strap a Raspberry Pi around your wrist, you can do it, but it really limits the scope. So if you can get away with really the minimal amount of hardware on your person and do all the other stuff somewhere else, let's say in the cloud, then you can really do much more. And also, the power consumption is important, because now there's a battery in it, here and here, so that's kind of okay. But it's a 3-volt battery, and that will last for a weekend, but that's about it. And if we want to do more special stuff, we for example, we used to have an accelerometer in here, so you could like, I don't know, make some movement and then it picks it up. I didn't make that movement. But it was, in that sense, we removed it because it takes energy, it makes it bigger, and it's not really necessary. So put complexity elsewhere where you can actually deal with it a little bit better. So, rugged. If I think about rugged, this is more the stuff I think about. First of all, your wearable needs to survive somehow. So we have done a lot of tests and seeing how well it holds up in water, for example, because it might rain, it might, all kind of stuff might happen to it. And also, the users are really not aware they're computer users at that moment. They are just having a thing around their wrist while they drink, fight, play in the mud, whatever. If people buy an Apple iWatch, they will cherish it and be careful and not play in the mud. But for our users, we can't really ask that of them. So we have soaked them in all kinds of fluids and see how long they survive. Actually, it turns out that leather isn't all that great. I guess there's a reason why submarines are not made out of leather. Because the funny thing is, if you remove the leather, you throw it in the water, you take it out, it's pretty much fine. Not forever, but it's fine. If you have it in leather, then it gets wet, doesn't get dry. So it is just in a wet sponge for a day, and then it's corroded, then it's dead. So leather looks cool. Huh. Okay, so another aspect of our of our gig basically is that it's around an event. There is a show time, and then it needs to work. If it doesn't work before, it doesn't matter. If it doesn't work afterward, also doesn't matter. It needs to work then. If it doesn't work then, maybe you can fake it somehow, but if it doesn't do anything, you're kind of screwed. So it is actually, we can get away with a lot of, we don't have to maintain the service, right? We don't have to maintain uptime for weeks or years. It's more like if you compare a racing car to a airliner or something. Airliner has to work every single time, all the time. A drag racer will have to work for, I think, like 4 seconds. And then you take it apart anyway, right? So we have to just make something, burn the stuff and probably also ourselves out in the process, and then we can move on. So that's quite different to most situations where you really want the uptime. So then it's nearly festival time, and it turns out that if you go to a festival, it is complete chaos. It's there are like 2,000 people building up, 60 companies. Nobody knows each other. Well, that's too much, but everybody is doing their thing, and everybody needs each other. So you try to get up in the priority of the other people. So, for example, we need network. So we are trying to find the network guys to make sure our base stations work. But the network guys also need the power guys who have to bring the generators, but the generators aren't there. And so it's like there is no planning there. But still, once you kind of embrace that you kind of emerge in that chaos and you try to figure out with all the people around you what you can do, you can actually do amazing things. And every single time it has worked out. And I've been amazed that actually with, especially like network people, they can be a bit grumpy. If you want I want this in this segment, it's not, normally it's not really a good response. But if you are in it together, because if those lights don't work, we all look bad, right? So it does create a sense of togetherness that I do not see in enterprise. In enterprise, you blame each other. So what we did learn, though, is that dependencies are on other parties' technologies are really, really annoying, because you just don't know what you're going to find when you arrive. We need power. The power is there, powered by generators, but yeah, at some point they arrive. Maybe they don't. I don't know. So we are working on battery-powered base stations that will work for a weekend, so we can just put them everywhere we want. We have made a pluggable network layer, so we can plug in different mesh networks, or maybe even simply 3G to process the data. And we are working on embedding GPS in the base stations, so you just put them somewhere and they can wire up themselves. You don't have to geolocate them yourself. Final thoughts. I need to check that, what my final thoughts were. First of all, I do have a lot of appreciation for operations guys now, because if you're in a situation like that, then everybody is on call, basically. Everybody is there, everybody is together, and network stuff is difficult. It really is. So they're not really They always say that it's difficult, but it's true. And it has been really good for me to get out of your comfort zone. Doing the hardware stuff, but also doing the festival stuff and getting a different perspective, because I look at how enterprise works in a different way now. Now I see how a festival works. I also look different at software now I've worked with hardware, and I can really recommend that to try it. Also, what I mentioned before a little bit, you can do amazing things in hardware. So nowadays, it is not outside your league of a small company to make your own hardware. And you can take that in your thinking, because our thinking ends at the end of software, but you can make hardware, and it's not witchcraft. I thought so, but it isn't. So actually it can add a lot to your app or thing, whatever you're doing. Maybe you can add some hardware. Maybe you can do really cool things. And that's my talk. Thank you.